like say HDLC, PPP protocols, those advanced protocols also will see it. Internet, those protocols are used, that will see it, right? And in this protocol, we have seen this, it is much more efficient. Efficiency will calculate, will see it, will see the expression for this in this case. But it is better than the stop and wait flow controls. In stop and wait flow controls, what you have seen it, one frame is transmitted by the sending entity, and the receiving entity will receive it, and after receiving this one, it send an acknowledgement. When this acknowledgement is received by the transmitter, then next frame will be transmitted. So that is the stop and hold flow controls. It's very simple, but it's a very slow process, right? So, and also link utilization efficiency is very poor in this, in case of whether the frame length. We have seen this, the propagation times, I mean the bit length. In that case, bit length, it is greater than the frame transmission times, or a greater than 1 or a less than 1. A means the propagation times, right? Propagation times greater than the transmission times or less than the transmission times. In both cases, link are underutilized. That we have seen it. And those problems, this efficiency can be improved if you consider this sliding window flow controls. It's a fast process. Here, multiple frames can be transmitted without acknowledgement. I mean, acknowledgement would be there, but that will be cumulative acknowledgement. Like say RR3, you can, in the slide you can see RR3. The means, it means that it has received these. Here frames are numbered. In stop and flow control, frames are not numbered. Here sequence number is provided for each frames. So here RR3 means here it has received the frames till 2, frame number 2, and ready to receive 3 onwards. That is the meaning of RR3. Computer. Hold. So that is a cumulative acknowledgement is the RR3, right? So multiple frames will be transmitted is more fast, and also efficiency will be more. Before that, you see the last time what I have seen it here, the frames initially A sets its window size, that I mean the number of frames it can transmit. It may be allowed to transmit. And B also sets its window that the number of frames it can receive, right? Next frames will be transmitted by the station A, station B. Here A is transmitting and B is receiving. So you see here window size is 7, and here the first 3 frames F0, F1, F2, these are transmitted by A, right? And as you have seen it, this as the frames are transmitted, window shrinks, right? And whenever it receives the acknowledgement, this A, when it will receive, that times window will expand. That's why the name is sliding window protocols. So now in the B also, when the frames are received, the window will shrink. You see 0, 1, 2 shrink, and next 3, 4, 5, 6. This 4 frames still it can receive. So by the time it sends the acknowledgement RR3, and as soon as it sends the acknowledgement, its window will expand, and total window size is 7. So 3, 4, 5, 6, and also another 3 frames. In fact, it is ready to receive not only this frame after frame number 3 onward, but also it can receive till 1, right? And when this RR3 is received by these ones, it window expands and it will transmit the frames 3 onwards A. So it is F3, F4, F5 starts transmitting, but as soon as F3 is received, we can send the acknowledgement, say RR4. That means it has received the frame number 3 and ready to receive the 4 onwards. By the time, so accordingly, here in the window, acknowledgement, it sends the acknowledgement, window expand, right? Earlier it is 1, so it is 2 now. This acknowledgement, and it has, you see, it transmits the frames, 4 frames, the window shrinks. And also you can see it here, by the times this RR4 reaches the transmitting stations, the other frames are already being transmitted, F4, F5, F6, right? So though it is received, the A is received the acknowledgement RR4, right? That means it should transmit the frame number 5, but already 4 onwards, but already it has transmitted 4, 5, 6. So A will not respond after receiving this one, right? Because unless it can open its window if and only if further acknowledgement is received by sent by B or received by A. Right? It can open window 7, the 7 onwards. That's why so further acknowledgement is needed. Anyway, so this process will continue. Have you followed anyone any questions regarding this sliding window flow controls? If anyone, if you have any question, you can ask. Otherwise, proceed. It's most important. That's why I have repeated this once. Any questions? It is here for this. Any questions?
No, sir. Followed.
Okay. So, that is thing is here. Now, in these connections, while this sliding window of these protocols, another thing is here. This example is showing here only one directions, but it can be both directions. Data can flow. You see, for full duplex or half duplex also, both the directions. I mean, both the station can exchange data. So one and whenever such things happen. I mean, both the station, if they transmit data and receive data, then you see 2 windows are to be maintained, one for transmit and one for receive, and each side is required to send the data as well as acknowledgement. For the it will send its own data to the other, and also it will send the acknowledgement to the other. Right. So these things can be supported. I mean, to meet this requirement, right? I mean, to save the communication capacity. Some feature is provided, which is called piggybacking. Okay, before iterative efficiency, what is piggybacking? That should also be known. Piggybacking. This procedure is used to save communication capacity. In this case, each data frame includes the frame number of the data. Also, it includes the sequence number for acknowledgement. That means data and acknowledgement both will be carried by the data frames. So, if a station has data to send and also acknowledgement to send, then it will send both together in one frame. So the frame contains the data as well as the acknowledgement, right? So this process is called the piggybacking. So if this feature is included, then it will save the communication capacity. Is it clear? Is it clear what is piggybacking?
Yes, sir.
And you see, and also this sliding window, it is much more efficient than the stop and flow control, because you see here the link can be considered as a pipelines that may always filled with frames in transmit. The pipe will be, it can considered as a pipeline, and the frames always will be there. But in case of stop and flow control, if you see, remember, in the pipe, only one frame will be there, because one frame will be transmitted, next acknowledgement frame will be transmitted. When the acknowledgement received, then other frame will be transmitted. So in the pipe, only one frame will be there. So huge capacity will be wastage. Capacity will be wastage here. And also in these connections, you see when there will be termination of this data exchange, if the stations, any of the station, if it sends RNR, if both the stations exchange the data, RNR command. RNR command means it is ready, receive not ready. Receive not ready. RNR. RNR. Right. This message, with this message, the data exchange can be stopped. If it is say, if for example say RNR 5, if it is mentioned, that means it indicates that RNR 5. Suppose B sends this command RNR 5. That means it has received all the frames till sequence number 4, all received, but no further frames will not be received by the by B, right? So that is the meaning of this. I mean, unable to accept any more frame numbers starting with 5s, right? But it has received all the frames till the sequence number 4. That is the meaning of RNR 5, right? Okay. So these things are there, piggybackings and terminations of this data exchange. These things are there. Now consider the iteration efficiency that just now I mentioned in the top. It is written here. So I'm just erasing. Okay, to get the space, sufficient space, and just okay. Now say that there are two cases. Suppose the window size, if it is greater than equal to twice a plus 1, window size is greater than the twice of the propagation time plus the transmission times. This is case 1, right? So in this case, you see maybe 6 such cases will be here. Let us draw the 6 snaps. Four, 5, and 6. So in the first case, it initially t equal to 0. This is A, station A, station B. A transmitting frames and B receiving, will be the destinations. Okay, this is at t equal to 0. Sets the window t equal to 0, right? And when t equal to 1, is the normalized times 1 means frame transmission times, then one frame will be transmitted. This is 1 frames, F1, right? 1 frame is transmitted t equal to 1, right? So if it is t equal to 2, then 2 frames will be transmitted. these are the F1, F2, F1, F2. Because distance, you see, we are considering the W window size. So depending upon this window size, the frames will be transmitted. T equal to 2. Now, in this way, 3, 4, etc. Depending on the window size, the frames will be transmitted. And when T equal to A, they are normalized times A. This is T equal to A, T equal to 2A. When T equal to A, that time what will happen? You see, propagation times. That means at the propagation times, what will happen? What you can expect? The first frames, the leading edge of the frames will just reach the B. And since the frame is quite large, propagation times, so frames will be continuously transmitted. So here in this scenario, the first leading edge of the first frames will reach next second frames. In this way it will come, and so here the frame A to frame A, and this is F A minus 1. So all the frames are being transmitted, and this is F1, F1, this is F2. Now at A plus 1, at A plus 1, can you suggest what you expect at A plus 1? Anybody? Can you suggest what A plus 1, what will be there? What scenario will be created at A plus 1? Can you suggest it? Anybody? Anybody can suggest it?
Sir, FA minus 1, then FA.
This is FA, this is A. I am asking at A plus 1, what will be the scenario? At the B, at the destination and at the source station. Which frames and what will happen at A plus 1? Yes, carry on. If it wrong one, tell me. Yes.
The A plus 1 thing will go, sir.
It will be, here will be A plus 1, no doubt.
Yes.
But what will be the B?
B will be, sir, F2.
F2, only F2 will be there, or some other things will happen?
No, sir, F2, F3.
No. That is F2 is okay. F2 though, these frames are there. Frames are in the pipe, right? That means here you see F3, F1 completely absorbed. One means one frame will be, same transmission times, and the absorption time is same. So one frame will be completely absorbed here. That's right. F2, F3, F4. In this way, it will be it is A plus 1. So it will be A plus 1. It will be FA in the FA minus, like these things. Some other things will happen, or just it will be so. That's my. It's okay. Up to this, it's okay. But other things also will happen. What is the other things? If you have followed just now I mentioned, you can answer it. What other things might happen? Yes? Anybody? Can you guess it? It's a protocol. You should answer it. Anyway, if you at least you guess it, what might happen at B or at A? No suggestion. Tell me whether any suggestion is is there from your side or not. Any other things? Any other things? Anyone? You see, if F1 is absorbed, what the B will do? You see the previous one. When the frames received by B, what happens? What the B generally B does? What the B does? Looking at this diagram. Looking looking at these diagrams, you can answer it. Tell me.
Sir, it is shortening the frame that can be received.
Yes, that means it will send the acknowledgement, isn't it? One frame is received, so it can send the multiple cumulative acknowledgement, or generally it will send the acknowledgement. As soon as received, it will send the acknowledgement. So acknowledgement will be sent by A. Of course, you can say multiple acknowledgement also can be there. So RR3 like these things after 2-3 frames, etc. So anyway, acknowledgement will be transmitted by B, right? That is one of the case. Acknowledgement after receiving, after observing 1 frames. Next, you see if I write it twice A plus 1, that means the acknowledgement will be received here plus 1, because same time will be this is ACK. So this ACK will be arrived here at twice A plus 1. At the same times, the frame will be, because it is frame size, window size quite large. So still it will continue to transmit. So here twice A plus 1 means it will be frame size will be twice A plus 1. These frames F twice A plus 1. Next frame will be F twice A. Like these things, it will continue, right? And here the since it is twice A plus 1, that means plus A plus 1 frame will be absorbed here. So the frame will be A plus 2. A plus 2, next will be A plus 3. F. Have you followed or not? You just tell me. This is so this is ACK at twice A plus 1, and at the same times you see A plus 1 is absorbed, at the same time acknowledgement will be received by the sending stations. Is it clear or not?
Yes.
Clear, right? That means here one thing is quite clear. You see in stop and flow control, you see the link is you see it or not always filled with, even 2 cases are there. Both cases the link is, you see, not filled with the frames, but here you see when the if you consider W greater than this twice A plus 1, you see when the acknowledgement is received, then also it start continue, it start, I mean it continues, the sending station continues to transmit, it never stops the transmissions. So it's a continuous process, right? Now consider the second case, when W, I mean frame size, it is less than the twice A plus 1, less than, is equal to, let us say, less than. This is case 2. So in this case, you see, first initially window will be fixed, window size will be set by both A and B. Next it is 1 as it is, same thing will be there, F1. You see this is frame F1, right? At next if you consider A here, just like this. In this way it will continue, we'll consider direct to A. So here as it is, when it is A, that means you see propagation times, the first frames, leading edge of the first frame will reach the B, that is F1, this is F2, right? And also here the frames will be, this is FA, this is FA minus 1s. Frames are being transmitted, right? Next, if you consider A plus 1, these times you see the A plus 1, that means 1 frame will be completely absorbed by B. Here it just reach. So at these times A plus 1, the frame will be completely absorbed, and here it is F2, this is F3. Here also the same thing. You see FA plus 1, FA. In this way, frames are being transmitted, right? Till now it's not a problem. So now 1 frame is absorbed, so now it will send the acknowledgement. ACK, acknowledgement will be transmitted by B. I mean, processing time, if you just neglect it, actually some processing time will be required. We have seen the protocols. You remember link configurations, that time we've seen it. Some processing time, but T processing we have neglected. It's very small times. And also we are neglecting the acknowledgement transmission times. Acknowledgement is very small frames, so that we have neglected. So as soon as the frame 1 is absorbed, B will send the acknowledgement, starts sending the acknowledgement ACK, right? And it is, if it is A plus 1, if the frame size is W now, W times T equal to W, this times you see W means the last frames, it is last frames. So here it is accordingly, if it is a W, then it is FW, next will be FW minus 1, right? And next will be here, in this case, you see, so it will be A plus 1 already it is here, so it will be just FW minus minus A minus 1, that means minus A plus 1, right? And next one will be FW minus minus A minus 2, so it is A plus 2, this one, right? And also in these wave frames will be transmitted, and in the meantime acknowledgement somewhere will be somewhere here, right? This is the ACK, still it is not reached here at somewhere T equal to W. Now if you write T equal to twice A plus 1, twice A plus 1, that times you see acknowledgement will be received. And since acknowledgement will be received here, acknowledgement will be received here, ACK will reach here, and also the same time, since W is less than the propagation times, here you see twice A less than this one, so already A will complete its transmission. A has adjusted its transmitting the frames, transmission of frames. So you see the last it was FW, last already, this is the last frames FW. So and in this way it will continue. So it is A plus 1, so here it will be the frames that will be F A plus 2, F A plus 2, next will be F A plus 2A plus 3, like these things. A plus 1 already absorbed, A plus 1 twice A plus 1. So you see it here, the link is, I mean here link is a little bit underutilized. Here it is less efficiency you can have it in such case when frame size is less than the twice A plus 1. But if the frame size is greater than this this one twice A plus 1, that times you can have the link, the pipe, it can be considered as a pipeline, and which is filled with always with frames. You see, always with frames, right? So in this case, obviously efficiency will be 1. So it's quite clear now. So in the first case, W, if you consider the first W greater than 1, so say A continuously transmitting the frames, so with no pause. So now the throughput, you can say throughput will be 1. Throughput will be 1 in this case. Throughput 1 in this case. In this case, so you see it here, right? In this case. But in case of case 2, when W less than twice A plus 1, A will exhaust its window at T equal to W, the last frames, right? And it cannot send additional frames till twice A, and whenever acknowledgement received, then only it can send the additional frames, next frames retransmitted. So the normalized throughput, I mean, at T equal to W, it completes its transmissions. So in this case, the utilization efficiency we can write. So U, that will be W by twice A plus 1, twice A plus 1, which is less than 1 always. This is the case when W less than twice A plus 1. Link is underutilized here in this case, right? But it is still it is better than the stop and flow controls. And in this case, it utilization efficiency equal to 1. Right? Have you followed? If you don't follow anyone, you can ask any steps. If you don't follow, you can ask anyone. Any questions? Anyone? Any questions? If you have any questions, you can ask. Any step?
No, sir. Followed.
Okay. And also, you see one figure in these connections. If you see it with the stop and flow controls, with the propagation times, you see. Say this is the maximum case 1. If you plot utilization efficiency U versus propagation times A. So if it is a 0.1, it is 1, 1, it is a 10, it is a 100. They are normalized 1000, like these things, right? And here, say it is 0.2, 0.4, 0.6, 0.8, and this is 1.0. So if window size equal to 1, then you see efficiency will be something like that. In these ones, this is W equal to 1. If you consider W equal to say 7, then you see it will be maximum efficiency, you can have it 1. Of course, it depends on the A also. Large values of A. This is say W equal to 7. Still higher window if you just consider this one, say W equal to 1 to 7. So you see it here, maximum utilization W for window size, that maximum efficiency that is available for different window sizes. 1, 7, 127. This is 127 with the value of A, different propagation times. The window size 1 means 1 frame. The 1 frame never will get the efficiency 1. But if you reduce the propagation times, it will be better. That you have seen it. But if A greater than these, I mean A greater than the transmission times, then is W, that will be the 1 frames. So if greater than 1, that means you see a serious inefficiency will result in case of stop and flow controls, but never to reach once. Sliding window flow controls, you can have once at a certain value of A, right? But very large value, when the very large value, that time you see it will deteriorate, right? But if you increase the window size again, you see it can cover very large value of A also. And generally, most of the applications, a window size 7 is adequate, but a very large window size it is required for high speed. This is for high speed WAN, high speed WAN, wide area networks. Say if different cities are interconnected with this one, then it needs WAN, or different continents are interconnected. That times WANs are required. Very high speed, high capacity links are there required. Right. LAN, MAN, WAN. Within a building, it is LAN. In the metro cities, within the metro cities can be MAN, metropolitan area network, and wide area network, large geographical area. That times it is WAN, wide area networks. So this is all about the flow controls. If you don't have questions, then I'll consider the next protocols. Any questions, or I'll proceed? Should I proceed?
Yes, sir.
Yes, sir.
Okay. Next, you see the error controls. We have seen the flow control. Now, error control protocols, you'll see it. Error control means, yes?
Sir, when A is increasing, why is U decreasing, sir? I didn't understand that part.
Give me just a minute. Yes, here, yes.
Sir, when A is increasing, why is U decreasing?
U will be decreasing, na? See, if the propagation, just think about it. Propagation time large. That means you see, when the propagation is large, obviously the transmission time, you see the frames link will be underutilized, na?
Yes.
You remember this one, link will be, there will be no frames. Even in this case of stop and flow control, it was quite clear, but in this case also, if you see it here, propagation time, window size is small. You see it here, W is small and propagation time is large. Have you followed? I mean, a link will be underutilized. A will complete its transmission, but in this case, A never stops the transmission. The link is fully utilized, so efficiency will be higher in this case. Fully utilized. Link is fully utilized. Link is fully utilized. Am I clear or not? This
yes, sir.
Is it clear? Yes. Then you can understand. Any problems are given to you. If this concept is most important. Silly questions will be there, but if you understand this one, then you can answer any questions. This here, based on this, is several questions will be asked. But if you clear this one, you can answer anything. Now it is clear. Now, same thing is depicted here also. You see it here. For a particular window size, you are having this 1 up to this a certain value of A. But if you say window size 7, you are getting 1. Maximum efficiency you are getting it. But if you increase even the 7 also, efficiency will decrease if you propagation time is large. You see it here in this case, efficiency is decreasing. Is it clear now?
Yes, sir.
Okay. See the error controls. Here you see error control means, what is the meaning of error controls? Means it can, I mean, to detect errors as well as to correct errors. That might happens in while transmission of frames. That is the error control. Here error control, not error detection, error correction. Both the things are involved. Error detection as well as error corrections. So in this case, we'll see several protocols. There are different error control protocols are there. We'll see it. Before that, you see what type of errors might occur when you consider such the frame exchange of frames. So there can be 2 types of errors. We are not, now you think about it, we are not considering the beats, we are considering the frames, and in synchronous transmission we have seen what is frame. Right. So 2 types of frames, 2 types of errors will be there when you consider the transmission of frames. One is the case, one case that be lost frames. It might happen lost frames. What is the meaning lost frames? Means that a frame fails to arrive at the destinations. What might happen? What is the cause behind it? A noise burst. You have seen this, it's a lightning, noise burst, impulse noise, right? So that may damage our frames. in such a way that receiver is not at all aware that the frame has been transmitted. So frame will be damaged in such a way that the B will be totally unaware of these things that the frame has been transmitted. So that is one case, that is the lost frames. Second case is the damaged frames. Damaged frames. These times frames will be received. A particular frame does arrive at the destination, but some of its bits. So frame is ultimately there, whether the flag control, etc. Those things are there, but some of the bits might be in error, right? When the frame is received, but if some of the bits are in error, that times it is called the damaged frames, right? And what are the techniques for error controls? To detect error, to correct, to detect and correct an error that we have seen. Several methods we have seen is, say, for example, Hamming code we have seen it, and parity bit we have seen it, CRC method we have seen it. So there are different techniques are there, and the techniques. So those techniques, those are one of the, but some other techniques are, apart from those techniques, some other techniques also there. You see, techniques for error control. So we have seen already error detection and techniques, error detection. The conventional technique we have seen, say, using parity bit, CRC, Hamming code, those things we have seen it. That we have seen it. Also, there can be another technique, like, say, if you use the positive acknowledgement, ACK, positive acknowledgement. What is the meaning of these things? If the destination sends a positive acknowledgement, that means the frame has been successfully received and there is no error. So by using positive acknowledgement also, there is there. If positive acknowledgement is there, right, that is the indication of successfully received receipt of frames. Another technique is there, that is called retransmission. Retransmission after timeout. Retransmission after timeout. What is this? Here, the source, the sending stations, retransmits the frames that has not been acknowledged after a predetermined times. I mean, here, actually, suppose A and B, they are exchanging the frames. A transmits, B receives. Now, when one case is there, this is one method where A transmits the frames and A is equipped with a timer. A will set its timer, right? A certain time is there. If within the certain times B is not sending, B may or may not send the acknowledgement, but if that acknowledgement is not received or any response is received by A, then and the time is over, timeout, then it will retransmit the frames, right? It will retransmit the same frames, right? So actually here A will keep a record of the frames that are transmitted. So these things are there. So that is another technique, retransmission after timeout. These things will be more clear when you take the typical examples. We'll see. But these are techniques. You see, another technique is here that will also used for error controls. That is negative acknowledgement. Negative acknowledgement and retransmissions. And retransmission. What is this case? In this case, the B, suppose this, the destination B, it sends the negative acknowledgement to the frames in which some error is detected. So it will send the acknowledgement indicating that error is detected. Then after getting that negative acknowledgement, this source will retransmit the particular frames. Generally, you will see it that we actually reject. Say if it is reject 5, that means you will understand REJ 5, 5. That means the 5th frame is in error, and you will, after getting this this acknowledgement, you will retransmit it. So negative acknowledgement and retransmissions. So these are the techniques that are used for error controls. And you see collectively, if you see collectively all these mechanisms generally in error control technique in data link control layer, collectively these mechanisms are referred to as, all these techniques collectively together referred to as the ARQ mechanisms. ARQ, automatic repeat request, automatic repeat request. That is known as ARQ mechanisms, right? And if you use these ARQ mechanisms in a particular protocol, that times the unreliable data links will be converted to a reliable data links. That times the unreliable data links will be converted to a reliable data link, right? So that is the case, and there are 3 versions of ARQ is there. 3 versions of ARQ mechanisms are there. Number 1, stop and wait ARQ is very similar to this stop and wait flow controls. Stop and wait ARQ, not exactly this one, some difference is here that we'll see it. Second one is the go back NARQ, which is most important and widely used technique. Go back NARQ, and third one, selective reject ARQ. Selective reject ARQ. So there are 3 versions of ARQ there. Just I'm giving the hints. Just one minute. Stop and wait ARQ. We'll see. It is based on the stop and wait ARQ. Other 2 are based on the sliding window of control techniques. Sliding window, when several frames can be transmitted. Here only 1 frame will be transmitted. Here stop and wait flow control, you know it. That is 1 frame will be transmitted. Next acknowledgement received. Next another frame transmitted. Right. But here duplicacy might be there. So, so to avoid these ones, in stop it and ARQ, what happens here? Frames will be numbered 0 and 1, and also acknowledgement will be numbered 0 and 1. ACK positive acknowledgement, they are numbered as ACK 0 or ACK 1, right? ACK 0, if it is sent by A, that means it has received the frame number. Only frames will be numbered as 0 and 1, 0, 1, 0, 1, 0, 1, like these things. So if ACK 0 is sent by A and A is received, that means it has received the frame number 1 and ready to receive the frame number 0. Right? If ACK 1 is transmitted, that means it has received the frame number 0 and ready to receive the frame number 1. So based on these things, you see the 2 cases, the lost frames and damaged frames, these 2 problems can be overcome. Next time we'll see it. Okay, today this much. If you have any questions, quickly you can ask. We'll stop it. Any questions? Any questions?
No, sir.
Okay. Just a minute. Okay, then next time we'll see it.